Hello, Twitch.
There we go. RayLean, 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 RayLean. Okay. So last time we were proving things about images, and um, yeah, like maybe you have done some other things since then. But I also went back and looked at Connell Elliott's denotational design presentation. So this is all, I think, really still when he was doing Haskell, but I think the ideas translate pretty well to a proving language.
Okay.
And so he had this idea of, yeah, but I can discuss it more, like, but maybe let me first check, like, what have you been up to?
No, well, I haven't done anything since last time, apart from set up the batteries dependency. So we have the rational
Mm,
numbers, and
nice.
I also have to I also have to report I spent several hours with Windows trying to get that to work, but it was a
Oh,
failure.
oh, thank you. That is, oh,
It
maybe,
just well, I don't know. I just after several hours. I think I just got frustrated because
mm,
it's an unfamiliar environment, right? And
yeah.
I got the package manager up and running, and but it's just like some odd stuff. I think maybe the Rust tooling needs more work, so maybe we do it without the SVG support to start with,
Oh,
and
okay.
and then
Interesting.
but I that was just the last straw. Like I got through several
Yes.
things, and the last straw was
Yeah.
like Cargo talking about Sigwin. It's like I don't want to use Sigwin. Like I just want
Ah,
to use the Windows terminal, and I want to see if it works on Windows. And then there
mm,
seemed to be some like dependency on Sigwin for Cargo. I was like, I'm out.
mm.
But
Yeah, that's annoying.
uh, yeah, so it's a bit of a so that yeah, so it's one of those things that I just need to go back to it at some point and
Oh,
then slowly chip away at it because I haven't used Windows in like
yeah.
20 years or something. So
Yeah, no, that's fair. I yeah, I haven't used Windows in a very long time, except the other day. But
I
like,
mean, the thing is that Lean claims that it supports it, and I'm
mm,
sure people do use it. And it also comes with a C compiler
mm,
already built into it,
mm,
which is all we should need. Apart from the Rust thing,
mm,
we just need Clang, right, to compile Raylib,
mm.
and then the rest of it is Lean, so it should work.
And what did you get stuck on in Windows? Like, what were the hurdles? Not what did you get stuck on, sorry.
Oh, right. So the hurdles is like, okay, so I want to use um like how do I install Lean?
Mm,
Well, I would normally just download the release tar or recip, right? But you need a terminal. And I only know like I don't want to use Windows command.com or whatever it was, like this
mm.
old fashioned thing. And so they've got something called terminal now, which is
Okay.
uh it's like a PowerShell
Mm,
terminal, but they've added like Unix style commands to it, so you can do ls and move,
okay.
and it's but if you want to, then you want to install stuff. So they have this thing called winget, which is like homebrew, but it just works in a very strange way. So you can't search for packages. So there's this other one called Chocolatey,
Mm,
which I was trying to use, but then you need to. Then I was like got stuck with all these error messages. It turns out you need to run the terminal in administrator mode,
okay.
and
Okay,
then
that's
we
fair.
should yes. Um,
That's the only one I forgive so far. All the rest I'm already questioning.
and then I've got okay. So Chocolatey I could install just, which is the command
Oh
runner,
yeah. Okay,
and
fair.
then that was fine. Um, but then then uh, yeah, then I had to yeah, I would try and get the Git client to work. Um,
Mm, mm,
so I eventually got through all those hurdles, and then I was trying to build, and it was complaining about uh, like some Sigwin stuff,
mm.
like SigPath and so on,
But
which
that
I
was
think
for
is like
Rust.
not what I want to use. I think it was for Rust, yeah,
Okay, okay.
but
'Cause isn't like installing
yeah,
Lean just installing VS Code and then installing the Lean package and then the package in the VS Code package manager
yeah. I mean,
and then
I just had to execute. I just needed like a lake.exe,
yeah,
and I just got the zip file rather than. I mean, if I use the VS Code extension, I've got to find where it's put it, and it puts it.
yes.
As I recall from
Yeah,
Windows, it puts it in some weird place
yeah,
that's
that's
difficult to
fair.
track down.
Yeah.
So I just wanted there's my executable file. I just run it,
Mm,
and
that's fair.
but
Mm, okay. Yeah.
anyway, so that's a work in progress.
Yeah. Well, thank you for looking at it. Just yeah, that's pretty cool.
But this
Uh,
is not the problem. The problem is like getting the C code to be Windows compatible. That's the actual problem.
that's the actual
And like
problem. It sounds like you didn't
all
even
this other
get
stuff
there.
is like solvable,
Yeah,
and it's
yeah.
just a matter of like becoming familiar with the Windows tooling.
Mm, mm.
They
No,
are
it's
trying. They're trying
very
very hard. Like you don't have to use PowerShell anymore if
okay,
you don't
cool.
want to.
All right. Sounds like you got quite far, but yeah, it's painful. For you, and will
But
probably be even more
for
painful for
non-Windows
me.
users, yeah.
Um,
Oh, and
yeah.
the RayLib 5.5 was released a few hours ago,
Yes. Yeah. Yeah. Oh,
which is
someone in the
exciting.
chat, Pyrex mentioned in the chat, just force people to use WSL on Windows.
Ah, this
I
is a
mean,
very good point. However, we want it to work on the Steam Deck.
yeah, we wanted, yeah, exactly.
That's the aim. So yeah, I totally agree. If it was just a matter of getting it running on Windows, we would
Hmm.
just use WSL. But we actually want to emit Windows binaries
Yeah. Yeah.
for running on the Steam Deck. Yeah, we didn't mention that part.
Not that we want anyone to play our games, but
No, we
but we
have
want to
one use
enable,
case.
but we do want them to be able to play it on Windows like they're just Windows users, but we have no users, but just uh it is still pretty cool to do. And yeah, it would be nice to play our games on the Steam Deck with an actual controller. Like I think it's a pretty funny thing to do. Um
Yeah,
so that's why no WSL. Um yeah. Uh I can maybe talk about the denotational design stuff
yeah, and
if we
then
wanna switch topic.
yes, and then yeah, I don't know. Maybe we can try and code some of it up.
Yeah,
I
yeah,
can,
I think it will.
but like, if you discuss it first, and then I can share my screen and we can.
Yeah. So I think the first idea is, well, maybe let's let me see. Let me open Visual Studio Code. I mean, crazy idea to actually write something down. Okay. Hmm. Okay. And then I'm just gonna save this file. Temp dot PS Haskell. Okay. Let me share my screen. Blah. Okay. I don't know what that was that I allowed, but
Oh, just before you start, this is something just bugging me
yes.
now. So the Steam Deck is Linux, right? So can't you just run the Linux binaries on it?
Yeah, but then yeah, then we need Arch Linux, but also
Yeah, that is. Yeah.
Also, they have a compatibility layer to translate Windows to Linux. I guess we could skip that and just go raw, but apparently there is some versioning issues that way. I think they just introduced something to bypass these versioning issues, like a stable version of Linux. So it's almost like a compatibility layer for Linux. Um, so they pretend like Linux is a Windows, and
But
just so that I
isn't
can.
Steam Deck is Linux, right? It's not.
Yes,
You've
it's
just
Arch.
decided to install Windows on it.
Yes, yeah, yeah, yeah,
So if we built for Arch,
yeah.
which then we could just run it on the Steam Deck.
We could try to run it. Yes, yeah,
Yeah, okay.
yeah.
But you want to run it? You want to run Windows on your Steam Deck?
Well, no, no, no. I'm happy to run either. I think it'll be cool on
Ah,
either.
okay,
Yeah, yeah, yeah,
okay.
yeah.
Yeah, we let's get that. It's not going to
But
bug me now, so
but I do think when we
I
have
can
actual
focus.
users, when we have
Yeah.
actual users, like Windows will be important, but we won't ever, so it doesn't matter. Or that's not the point, at least. But okay, so let me try to explain this. So in very short terms, okay. Well, first, okay. So Connell says, well, he does this whole discussion, like it's 2.5 hour talk. It's pretty good. I guess it's my third time or fourth time watching it. But
Mhm.
he says, well, what is an image, right? And he has like a 30-minute discussion with the group, but he's predetermined the answer, and he kind of
He's
knows that's where they're going.
guiding the users, guiding the
No,
people
he
to the
knows where they're
answer.
gonna land, and like,
Yeah.
and he's open to being wrong, like, but he does end up landing in this place, which is an image. If you just, I'm just writing on the text here, but so an
Yeah.
image is a mapping from location to color.
Yeah.
That's so instead of having these, well, these could be 2D locations, right? Just to so
Yes.
basically,
Yes.
rational. Why can't I type rational? Rational color, right? And so now you have like more of a denotation than a representation, right? This could be a map, this could
Yep.
be a matrix, but in the end, this is all it is.
Yep.
And then what he also says, well, what is a region, right? Well, a region is a mapping from location to bool. So you can say where something is in a region by checking all the locations and saying whether they're. So then this becomes interesting. So actually, a color image is a mapping from rational to color, and a region is really an image of type bool. And you can say an image of A is just a mapping of locations to some A. That's pretty cool. Uh, and then he's got some operations, but he also shows an image is a monoid when A is a monoid. Okay. And he's got various lift operations. Or, oh, let's go find some operation. Let me just open the slides quickly on this other screen. Well, maybe I should just open it here. So this is the link for anyone who's interested, which has a lot of links. So let's look at this. So basically, I saved you all of this time over. Okay, but here's the operations.
Yeah.
Okay, so we have. Okay, I think we have actual code later. So here, right? So I'll just take a screenshot of this. But basically, monochrome is just something that takes a location and always returns the same color. And you can crop a region. You can say if the location is if the location is in the region, and sorry, I've been going a little bit too fast, right? This mu is the denotation. Okay, so if the location is in the region, then show the image. Otherwise, show clear. And I can't remember what clear was. Okay, we'll have to come back to that. And overC is a function that takes two colors and returns a color. So if you have one image over another, well, maybe you just return the top color, but like this is probably
Yeah, you
some.
could different choices there, isn't there?
Yeah, there's quite a few choices here.
Yeah.
Yeah, interesting. And so yeah, I think we've discussed these three operations, and then he just refactors them a bit. This is not interesting. Okay, okay, but then he has these lift functions, and he says, okay, lift A just takes an A and lifts it into an image. This is the monochrome function because it takes some color and just returns an image of that color. This lift that takes an A and a B and an image from A to B is actually a functor.
Yeah.
And this one is, yeah, so here he shows, yeah, monochrome is lift 0. Over is lift 2 with the over color function. Crop is the conditional, so it just takes, this is the region, so just, yeah. I don't know if I have to explain it, like, it kind of makes sense, right? This is sort of an if then else. If this image, then this, otherwise that image. And so crop can be built using this condition because you just return the empty image when it's false. Okay. Yeah. Some transform stuff. I can't remember. And then, okay, I think this is the monoid part. Yeah. So the mappend is over. So I think I think that over C has to have some properties. So remember that the two colors were mixed. Well, I think if the top always goes over the bottom, I think it is. I think it is still a monoid. Am I forgetting things now? Yeah, because it's associative.
Yeah.
but it's not the switchy one.
Yeah, we don't. It's not required to be commutative.
Yeah, commutative things. Yeah.
Yeah, but and then this epsilon is an identity, even if you
Hmm.
uh, yeah.
Yeah. And then, oh yeah, clear is transparent. That's the color. Yeah. And yeah, that's about it. Like,
You get this lift two from applicative. So
um,
you get functor, and then applicative gives you the lift two. Yeah.
you are absolutely right. See, so this is, yeah, I think his point is you can actually guess. So in the end, this is just another talk to explain monads. But
Yeah.
it I do like the representation of the image. I
Yeah.
don't.
So I mean, we could. I mean, we could do that exact. We could just implement this exactly because
Hmm,
yeah, we could just draw pixels on the screen. I mean,
hmm.
but we don't. We could just then that is just we're not using any of like the STL primitives or whatever for drawing stuff. Um,
Yeah, I think we lose
you could
something though, but I'm almost more like for the image we want to prove things about, it might be nice to say an image is something from location to color.
yeah
But I don't know in practice. And I feel there's a version of his talk where he does show all the images he generates with this, but for some reason I couldn't find it. So that was sad. But maybe I should just look again.
hmm
Maybe it's this one. Yeah, yeah, okay. Okay, so
I like this one.
that's an image.
Yeah.
So maybe it's here. You would think there'd be a GitHub repo.
That's the library pan. So maybe the pan is the
Okay. Okay. Papers, I guess.
looks suspiciously like Comic Sans.
It definitely is. Okay,
Uh,
that's a good
they got
one.
a download on the previous page. Maybe
Okay.
they just ship a binary.
Do you see download?
Yeah, the last image, the last robot on that, the top the whatever
Oh.
you call it. Yeah,
Oh.
I don't know what
Hello,
happened.
robot.
ActiveX controls. I think you're not allowed to use those anymore.
Which one's this? Actually,
ActiveX, yes, they were just a massive security hole.
yeah.
We need to get like a Windows 98 up and running.
Okay. Ooh. Okay, tutorial. I mean,
Maybe you can write plugin. These are for plugins.
yeah,
Hmm.
but then yeah, so there's rotate at least. There's
Yeah,
there's
so the
scale.
different transformations.
Yeah. Mm. Yeah, that's also good
This
to.
would be like doing a lot of doing the not only like the game engine, but the graphics library.
Yeah.
So basically, we would just use Raylib to. We'd only need Raylib to write pixels to the screen. We
Yeah.
do everything.
Yeah.
So we don't even need Raylib then. We just can use SDL directly because the only API we need is like write this pixel.
Mm.
Interesting.
Yeah, maybe that is overkill. I'm wondering, like,
No, but I think the principle maybe we can I think maybe we already even started doing it, which is like we have some um yeah, we have some abstraction um for a composable abstraction. So
mm,
so we don't have this thing, but we have a monoid structure for primitives.
yeah.
Um well, I don't know exactly how similar it is to this because they're not functions, are they? They're like hmm. Yeah, so what's playing the role of this mu function?
Well, that's just the denotation, right?
Mm.
So we we could have some representation of the image that actually goes. So for example, ticks, right?
Yeah.
That's pretty tough, right? Um, but it is also just a map from location to color. Now, do we have access to this map? No. This is inside RayLab, right?
Yeah.
So we can say like, hey, we do want access to this map. And then we need to write our own RayLab.
Yeah.
Or we can say no. But let's take another example. An SVG. Can we get access to the map? Maybe.
Uh,
Uh,
well, you'd have to compile. I don't know. No, the thing is, though, the
the
process of
answer
going
is
from no,
no.
no, no, the process. So, in terms of isn't this what rasterization is? So you have like in Raylib, you have this process of rasterization where you take what your description of the image, even in like Raylib, and then it gets rasterized into this basically massive array of just
Mhm.
pixels. And then your array of pixels is a map from location to color. This is like quite low level.
Your well, it depends. So that is a very good point. So like, yeah, then you do get a map
Yes.
from location to color, but that rasterization might already have taken away some preciseness, right?
Yeah.
So because you're going to give it some resolution to rasterize on, and
Yeah.
the idea of this representation is more to still be very precise
Mm.
and not necessarily be performant, but be precise and simple. And we would once you rasterize, you do lose some precision.
Yeah,
You kind of want to rasterize lazily. You want to say like, okay, given a point, now rasterize and check if I have a color at that point. Super slow.
yeah,
Uh,
no, yeah, I think it is. Yeah, actually, I've explained it. I
given
think it's
our
a completely different
examples.
object
Hmm.
because this is like, yeah, location is some idealized location, right? And in
Yes.
the pixels there's some like resolved location,
Yes.
but it's like far too coarse.
Yeah.
Um, so the other thing is, so if you actually represent an image in this way, like a location to color,
Hmm.
then can you? So the thing I was wondering about that I can't see is like, can you recover from that a description in terms of these higher level primitives? Like if you give me a function location to color, can I decompose that into like rectangles and circles and lines and
No.
yeah?
No.
So that
You can decompose that into an image on screen, but not
yes,
not into no lines and squares.
yeah,
Yeah. So it's more like you want the yeah, I don't know. But you could have the RayLab representations, and then your proofs could be about things from location to color, right? But once you add takes or SVG or something where it's just a little too hard to go from to go to the function from location to color, then you can't prove anything. So um, yeah. But what's pretty nice is you can have this in an abstract way. It's really cool because you can have your whole game like like, and then only once someone calls location to color, you care about that piece of the screen. Um, so you could have relatively efficient rendering for your game world where it just looks at your state and goes, okay, I'm calling it on this piece, and yeah, and only then does it really figure out what the color should be at that position. Well, maybe.
yeah,
Depends how you represent that. Um, but it is nice for moving the screen around. Like I feel like it would work pretty well for that. But it's like you say, you basically, well, we're gonna do pixel per pixel.
yeah. So you'd have to write like an OpenGL or SDL like renderer.
Mm, mm. And then we have to also, is that fun?
No,
Okay.
because we're just
Then
doing linear algebra at that point. Like,
so we're not doing it. That's the answer.
well, we'll write. We'll see. We'll write some games like in 10 years' time or something like that, and then we'll
Yeah.
find out it's not performant enough.
Think like our main use cases for drawing
Yeah.
for these simple games are, yeah, we do want takes, we do want SVGs, and we want some areas with textures.
Hmm.
Uh, that's the first level, and then maybe we want some lighting at some point.
Right. So like shaders or whatever these
Yeah,
things are. So this is like
yeah,
GPU stuff.
yeah. I don't know how we're gonna do that at all. Um, but yeah, and then yeah, we do need to move the screen around. at some point for some games. And we do need to scale up, scale down. But it's only at those places where this library feels like very valuable, and for proving things, which is kind of fun. But doing all the things we need to do to get to that, wow. I don't know.
So how would we? You'd say you'd have a circle function, and then
Hmm.
it would generate one of that you would it would output one of these location to
Hmm.
color functions.
Yeah.
Um,
So then you
yeah.
loop over. Oh, hi.
Oh, oh, hello, Keegan.
Hi, Keegan.
Hello.
Hello. Welcome.
Yeah, thanks for coming.
Pleasure. Pleasure. It's a bit of a mission to get my camera sorted, but I got it working.
Nice.
I'm
Cool.
using my phone because I just have a PC, so no need for a webcam. So,
No.
and my laptop's on Windows, and I knew RayLean wasn't working on Windows yet. So it was either get RayLean working on Windows or just figure out how to do the webcam with my phone. And I thought this was easier.
Okay. Well, I think you made the
So
right.
we should try and make it hard for you to use your webcam to encourage you to start figuring out Windows.
Yeah. Yeah.
Yeah.
I don't think that's going to happen though.
Yeah, I'll give it a go. I'll see how difficult it is. I installed everything now,
Mhm.
Yes.
but I don't. I tried just like building the RSVG because like I used Rust on Windows before and it like worked fine.
Okay. That's good.
But I got like a weird error um, trying to build it, so I'll have a look at it later. And
Did it
then
ask for Sigwin?
no, it was like the copy command like expected too many arguments for some reason. It was like it was just errored out because
That's
so
not.
Yeah.
yeah. Um and then building Raylib's gonna be like you're gonna have to force them to either so if we want it to be proper, then we'd have to like support both Visual Studio, the Visual Studio compiler,
Mm.
and there's like MinGW or something like that, which is also
Mm.
popular. So
Mm.
and those are both supported by Raylib, so it'd be good to support both. But I hate working on Windows, so
Yeah.
Yeah.
For me, I don't know if I hate it yet. I'm just like, I hate it, but I don't know if it's because I hate it or I'm just unfamiliar with it.
Mm.
it sucks.
So,
Like,
yeah.
yeah, it's not good. But apparently WSL's pretty good on Windows now. So yeah, but it's
Yeah.
not
We
the
can
real
just
thing,
use that.
you know.
Yeah, that's not the same. That's
That's the cheat. The
yes.
cheating way of doing it.
Oh.
Mhm.
The other way is to do WebAssembly, I think.
Yeah.
Oh yeah. That sounds like fun.
Does
Yeah,
it?
there's
I
there's
can't
a
read your
reason.
face if you're sarcastic.
Nah, the thing. Well, I don't know. There's another reason for trying Windows, which it's like a work project. I wanted to see whether it would work with Windows. So
Mm. Mm. Okay,
that was
cool.
another reason.
Okay, fair enough. Okay,
Anyway, so we're still
so
debating about what to do.
yeah, well, yeah. I think it sounds fun to prove things about location to color. It doesn't sound
Yes.
fun to redo our core library to work with location to color, and we're here to have fun.
I think it's like how it's very tempting because, as I just said, if you have this location to color function, you can just evaluate it, and then there's a RayLean API for just writing a pixel to the screen.
You
But how hard could that be?
bypass all of RayLean.
Well, yeah, I mean, you just use this one API. How hard could that be?
So for
we don't even need RayLib then, or so that should make it easy for Windows.
Well, yeah. What's also interesting is you could say for any image you really want to prove things about, you have to use the pixelated image, right? Which is the one that you can map from location to color. But we still support any other type of image. It's just a sum type where one image you have proofs about and the others you don't. You don't have to disable yourself immediately. You can go, okay, actually this we can support with RayLean, or these provable pixel images are horribly slow and we don't know, we will never fix it. So let's not use it. So we can do this in between thing where we get both while we figure it out, because we don't know what we're talking about at the moment, like,
No.
or at least I don't. So like, but this way we can have both because RayLab allows us to do both.
Yeah.
So that's one. We have to decide if we want to write a game or an image library. That's also a decision. And
an image library and a game engine.
Yes. And like one thing I think that will make it like more obvious to me whether this image to location thing would work is even if you have only SVG support and you can get image to location, you could write text in SVGs. Like,
yes.
It's not that hard. You could do anything, like, so if we have access with re-SVG, right, we get an SVG out. A parsed one that, well, I don't even know if we do, but like somehow we pass this to RayLab to draw. How does that work again? Maybe let's start.
So you convert. So the API for RayLib is textures. So you get to draw textures, and then you just make textures out of SVGs.
Okay.
So texture is like a RayLib type.
Okay.
Yeah.
What is that?
Oh, a texture is I don't know what it is, but
can we
if you can build one, yeah, let's look at it.
For me, it's clear. Like,
okay, great.
If texture is gives us access to location to color, then it's kind of done.
Okay. Am I sharing anything yet? Oh no. Okay, there we go.
Yes. Cool. And because then we just need to build a lighting library as well. On top of SVGs. I mean, how hard could it
be? So I forget how it works now. So SVG.
I think there's just people their whole lives doing lighting, but I'm sure we can figure it out.
Yeah. Okay, so you make an image, but then you need to make a texture. So I don't know what this is, but to me it's just opaque. So you load an image, and then you get one of these types, and then there's some other thing that says like textures. I think that's what we do. Load image from texture. Yeah, texture. Yeah, so you load texture from image, and you get one of these things. Yeah, so here we go. So it's this min-maps thing. I think this is like equivalent to the location to location to color.
Well, you also see
Well,
images
sure.
right above. Images defined right above.
Oh,
So
so image raw data, and then you.
I think texture just, well, loads it into the GPU. So that's why
Yeah, that's
it
true.
only needs an ID to render.
Yeah.
Interesting.
Here we are. Image. So this maybe it's this data that is the pixel data.
Yeah.
So.
And that's also why I think if you go back to where you load image from SVG,
yeah,
the parameters.
load image SVG.
Yeah, you see, you provide a width and height.
Yes.
Which means it already does the, as you said before, rasterization.
Yeah, it does the rasterization at this stage.
Yeah. So that's too early.
But I'm not sure. Let's double check. What's it find? What did I call this? Because we do this part confused me. I think that load image from SVG is a bit broken.
Okay.
Which is why we had to do this.
Aha. Yes.
Right. So, right. Yeah, this is it. So, well, it's at this point we actually do the rendering. And you notice this is the image that gets put in the this is the data that gets put in the image is the output of SVG render. And so you give it a width and a height here, and then you can set this to whatever you want.
Well,
but you ask the SVG file for its width and height, because you can specify it in the SVG file. Well, that's how I did it here anyway.
That's good. That's very good. But there on line 154, you also pass a size. I just want to know, is that just the size of the buffer?
Yeah. So that's the size of yeah. So that's the size of the data. So this is the file data.
Yeah.
That's the size of the file data.
Oh, okay. Even better.
Yeah.
Okay.
Yeah, because this is in parameters, not out parameters, because it actually returns an image. So yeah, you actually pass in the data. Then this thing, because the SVG is like an XML file, so you pass it first.
Yeah, nice.
And then so it's nothing to do with the size of the thingy.
Excellent. Okay.
So we can do the scaling here.
Yeah.
For example.
Well, we don't have to. That's the thing. Now we have the original. And for location to color, we want everything to stay original until the point of rendering.
Right, and the point of rendering is here.
Yeah, but we will push this out.
Yeah.
Because what we really want from this load image into Lean, right, is not to render it.
No.
We want to render pixels.
So how does this work then? So what would this output then? So it wouldn't output the image because that's the rendered thing. So it would output what? The parse tree?
Yeah, kind of the parse tree, yeah, exactly. Which
and then what would you ask? So when I have my location to color,
yeah.
So at some point I'm going to have to render this thing. So I would have to know its dimensions at render time.
Yeah. You'll save the original width and height.
Yeah. But you might scale it, right? You might take your SVG image and then scale it.
Yeah.
So the width and the height is going to come from the so it'd be something like you plug your your location into your location to color function,
Mhm.
and then you'd notice that you're inside a region that was this SVG thing, and then you would render the SVG, and then ask for the offset width and height.
Well, no, you will ask the SVG, what is the color at this point?
But to do that, I have to render it, don't I?
I'm gonna hope no.
I think you have to render it.
Because you're rendering it to the screen, right?
No, no. This is rendering it to this image data.
Yeah, that's pixels.
That's pixels, yeah. But there's no API for asking this thing anything. Like you can't say what would you render at this point.
Oh, you can't. Okay.
I don't think you can say that. You can only render it, and then you can ask what it was rendered at this point.
Mm.
Because this gives you this gives you like the 2D array of pixels.
Okay.
Or whatever this is. I forget what this is now, but I think for each pixel you get, well, it looks like you get 4 bytes. Whatever
Yeah,
that
for
means.
the color. Yeah, that makes sense.
Yeah.
Okay. Okay.
So maybe I don't think there's an API for this. So you can say, what does this render tree do? Yeah, the render tree. Creates a render tree from file. Passes a render tree. Ask if it's empty. Turns true if a renderable node with such an no. Get bounding box exists. Destroys the render tree. Yeah, I'm not sure what that means.
Well, it's basically some parsed XML, right?
Yeah. But I'm seeing if it has an API for
Mhm.
asking what the pix or what the yeah. It doesn't have any API here for asking what the
Yeah, so Python says, but isn't this kind of rendering more shader-like? I mean, you call a function to decide what each pixel's color is.
I don't know anything about shaders, but so this could be what we
Yeah,
just what we need.
but that sounds right.
Ah. So could you explain that a bit more? Is this what this is talking about here? Like I got a shader and a shader locations array, but
Yeah, he's well, they're in the chat, I don't know. But that sounds like we have to learn what a shader is.
we don't know. What is bone? Oh, skeletal animation. What?
Yeah. But
All right. So if you want to render skeletons, then you're fine. Like,
okay,
you're
okay.
covered.
But this shader does sound very compelling. It sounds almost like a region. Like render these regions, right? Render this region, which is a list of locations.
Okay, so
That's what it sounds like to me.
how can I make a shader? Oops.
Yeah, how about we shade something? Let's shade something from Lean. Like, I feel like we're designing an image library, right? And we have no idea what we're doing.
Let's see. Shader. What functions can you do with
purple? It's a purple.
Oh, sorry. It's a whole. Okay.
Oh, lighting. Oh, perfect. Yes, that's what I was worried about.
Where does the shader come from? Oh, so shader is some file.
Is it always?
Do we have
Can we
to-
look at the more basic example? Maybe there's like top one is. Oh, that is the top one. Okay, cool.
Yeah, maybe this one is okay. Palettes.
Hmm.
We have to generate a shader. Palette switch FS. I don't think I have the.
No, no, that's fair.
I think I deleted all of these things out of the. Yeah, I deleted them all.
Oh, okay. Items is I'm not an expert myself, but as far as I understand, that's what the GPU does. It computes the values of each pixel in parallel. The thing is, shaders are programmed in their own shader language, so we would need to compile it, I guess. Since they're not executed in the CPU, but the GPU. Yeah. So we're trying to do the GPU's work, which is not a good thing. That will make our game very slow.
So GLSL must be this shader language. I'm curious to see what this looks like.
Yeah, me
There
too.
was a VS and there's an FS.
F sharp.
F sharp.
F sharp.
There we go.
Yeah,
We're using the wrong language.
Yeah, again.
F sharp.
We need to write our shaders in F sharp. Oh no. Just when I thought we didn't have enough languages.
What? This looks like C. Is it F sharp?
I mean,
I think it's
yes.
supposed to be close to C.
Ah,
From my brief googling of what GLSL,
Okay. But I'm gonna go with it. It is F sharp.
it is
Yeah.
F sharp.
Yeah.
Because
And
you could do for loops in F sharp
Yes.
or
Oh,
while
yeah.
loops. It's insane.
Cool. Just like in Lean. Okay, what is fog? Let's see. There's some light.
are you sure it's F sharp? F
No,
sharp
I'm
has a C
kidding.
preprocessor.
I'm kidding. I'm
That's a bit
kidding.
boring.
But why not?
I mean, Haskell, you could enable the C preprocessor in Haskell, so why not? Yeah.
Okay,
It's just like you don't, you just in.
Yeah, but look at the top. Look at the top.
Okay.
You have in vectors and out vectors, right? So this out. So basically, I'm guessing, right?
Yeah.
But you are giving the GPU some matrix multiplications to do, and
Yes.
and that's why you're specifying what is the inputs and what is the output, and yeah. So your shader is kind of like it is a function.
Right. And then you're mutating this final color business.
Oh, okay. Okay. Aethon says, yep, shader languages are like C, C++. We need a lean GPU.run, like we have an ID.run. So we obviously need a do notation for GPUs. Yes. I agree.
We can add this to the backlog.
That's a good one. Yeah. This is a very deep rabbit hole. Like we could just make a game.
We could make no, it's not.
But we do need to learn how to use a shader. Because yeah, we'll need this to do any type of lighting, right? So
all right. So it sounds go ahead.
So what if we did a ray tracer
A
'Cause
ray
they use-
tracer. Oh, for lighting, yes.
Yeah, you could do reflections, lighting.
That's true. That is true. And they're apparently they're fast enough now. Not that the one we will write will be fast enough, but someone has gotten current day hardware to do ray tracing, right?
We have like specialist hardware, even more
No.
specialist than the GPU.
No, I don't think it. Well, I mean, not more specialist than the GPU, no. I think some new games have ray tracing built in, like.
I think they're adding it to Half-Life 2, which is crazy.
Oh, really? Wow.
Yeah.
So it's the 20th anniversary of Half-Life 2, right? That's the.
Yeah.
So you can get it for free on
Steam.
on Steam, and yeah, it's a pretty good game. It's a fucking amazing game. Or it was for its time. I think it's still pretty good.
Mm.
Because the physics are crazy. Like you could throw objects around. You've got like a gravity gun, which is just yeah, insane. But all the guns are pretty lame compared to the gravity gun. Yeah. Okay. So, but yeah, for this 20th anniversary, they also decided to write some extra code for it. I think that's what maybe that's why they're adding ray tracing, but
I don't know. It's RTX, so I imagine it's only going to work on an NVIDIA GPU.
oh, okay.
I would
That's
imagine.
not specialized. That's just new.
Mm.
That's good. Okay. So I don't think we're gonna learn how to write a shader in an hour. Okay.
No, yeah.
But it looks cool and it's definitely something. Oh, Ithon says that Minecraft has some ray tracing.
Yeah.
What?
They do. Yeah.
That's okay. Oh. We really went down the rabbit hole now. Okay.
Right. So, what should we try then?
Let's
I've lost.
just take a sec. What are we doing here again?
What are we doing here? Well, I mean, we can try Connell's approach because I mean, so what I wanted to check was you can just draw a pixel, right? Pixel. Oh, very good search. I thought there was a draw pixel API. Yeah, here we go. See, there's
Okay.
there's your map.
Yeah,
That's all you need.
We could do that. It is a
Or I mean, you can be fancy and stick it in a struct if you want.
Yeah. We could do that. It is it's a manageable piece of thing to do.
Yes.
And or we could play around with orbital. But yeah, we could, since we're down the image path, we can play with this. But yeah, give me a nice way to draw a pixelated game.
Yeah. So this is what we had last time.
And I think we can even go take this SVG, render it to this max size, and that I can still then ask this SVG what is the color at this pixel given the C image type. Because the image type in C is just a matrix with the colors. So it is possible to write some code to get access to that we just don't have at the moment. But it does future-proof us for SVGs. We do not get shaders.
No.
But we could apply shaders on top, possibly. But yeah, I'm not sure. We have to learn about shaders, I think. That is, I think, probably pretty important. Okay, you want to play around with image denotation?
Yeah, let's do that.
Okay.
Well, there's a few things that now this syntax is deprecated.
Oh, we started the file.
Yeah. What I mean is, I just want to point this out because this is was new to me with the new version.
Oh,
there were multiple ways of there's multiple ways of defining an inductive.
Yeah.
I think you can do this, which we do in some places.
Oh,
but now that they're going to get rid of that, and you use where.
Okay, that's fine.
I think there was another way of doing it as well. Yeah, so you can actually just write. I think you can just write that as well.
Yeah.
Oh, that is not deprecated. Oh, interesting.
Not yet.
Okay. All right. Let's plop it here. Call it image.
Yeah. Okay, so we need an image as a generic type A. That goes, well, yeah, maybe it is maybe it's a div.
Isn't it just a? Oh, image.
Yeah.
And how do we do it? Like this.
Oh yeah. Yeah, that's correct. Colon equals. And then that is something that goes from, well, a tuple of rationals.
Yeah. I need to import batteries.
Okay. Just like that?
I think, yeah, I was it's, yeah, let's see.
Rat.
Oh, don't write it like that. I was looking at the yesterday.
Rat.
Rat to Ola. Oh, hey, sorry, yes.
Yeah, cool.
So I think this works. Yeah, so batteries, it does its namespaces in a slightly different way than we do. So most, like the data types are in the root, like unnamespaced. And then if you want to use anything in rat, you've got to say rat dot.
Okay.
It's actually quite an interesting way of doing this. So maybe we're doing it wrong.
Yeah, I definitely feel like we're doing it wrong. I just don't know what the right way is. Okay, so we have this. That's our like denotation of an image, not our representation. Okay. Now we need, well, we can make a location type, which is the just the tuple.
How do I do this now? It's just
on line 40 on the other side. Here's an example.
Oh yeah. So what do we call these things? X and Y?
Yeah, why not? They are yeah, that's exactly. Cool. And then okay, now we need.
What is a good thing to open on the PDF of this thing, just so I can have it here as well? The paper or the?
I went with the PDF. The
slides.
Yeah.
What does builds mean?
I don't know what builds means, but I went with.
With. Okay.
Yeah. So now I think we Yeah, we want to scroll down to maybe the left functions.
So yeah, so it's got on page 15, it has this thing here.
Yeah, that's the denotation. So yeah, we could make that a function that takes an image and returns the location to A. That is yeah, maybe
What is this? What is this type? This type is
doesn't say. That's up to us.
but then at some point it's indexed by something.
Yeah. But the color or bool to be
Yeah.
a colored image or a region.
Okay, so my brain is not working. So
okay,
how do you write this then? How do you?
We've not decided what that is. So
Okay.
Like I erroneously said it was the type. Okay. But if you think of it, if we go think about what we've done with regexes before, right?
Yeah.
You have the representation of the regex, which is our inductive type. Then we have the type that is our denotation, which is string to prop.
Yeah.
Right. And so but that still has a type because it's nice to have that shorthand. And for me, image is that type. But it doesn't have to be that way. But that's yeah, maybe I didn't.
Oh, that makes sense.
But that's the decision I've made. That's not necessarily a copy of what it's done.
Yeah. Okay.
Yeah, but now we can write these functions.
Lift, transform.
Yeah, and I think the next slide might actually show. Well, almost. Well, we can write those functions. They're not too hard. I think.
Yeah.
Let's see.
Oh, I meant to. I can do this thing.
Oh.
Do I want to do that?
I mean, no. Why not?
What's this complaining about? Stuck at solving univ. Oh no.
Oh, so just say the online 7 type U and
yeah.
First type U and then type U plus 1.
Yeah. Do I type it like that?
Yeah. Exactly.
That is it. It's actually complaining. Oh, type mismatch. As type, expected to have type.
Okay, I'm just checking something.
No, but the thing is that if I write type, that's like type.
Hold.
No, it's fine. It's fine. It's just confused.
Okay.
I don't know. I was going to say that's. Yeah. Okay. So the pass is just.
Yeah. Okay. As def.
Def. Sorry. Yeah. So this is.
Yeah. Oh, you have it open.
Oh yes. Just
I need to open it as well. Okay, left takes an A.
Let's use the.
Oh, the lean way.
Let's do the lean the way.
Yeah. Nice.
It takes something of A.
No, well, an alpha. Like you can't.
Alpha, sorry.
No, don't screw me now. Oh, I see. Yes. Okay, and then it returns an image of
image alpha.
Mm-hmm.
And then this is just const A. Oh yeah, but lean doesn't have const.
Mm. Okay, yeah, it's okay. We'll survive.
Yeah, okay.
There we go.
There we go.
Nice. And then
Lift
yeah.
one.
So it takes an A and a B.
Yes.
Well, a function from A to B, sorry. Yeah.
I'm gonna do that, isn't it? Mm.
What are you doing?
Yeah, I don't know why it does that. I'm sorry. Yeah.
Okay.
I want to write it like this.
Okay, cool. Nice.
Oh, rewrite this.
So we take function. It takes an A.
Yeah, sorry.
And then, so that's our, and then just if A, I guess.
Let me go open the tab thing.
Oh, no. Oh. No, you have to.
They have to return a function. This needs to be a fun, right?
Yeah. That takes a
B
B.
to, oh, no. No, it takes a location. So this is a location.
Yeah.
Yeah, sorry.
No. I'm still thinking about it.
So this is a function. And what does the function take? We have to return a function, and the function takes an image. And an image is a function. This takes us from location to A.
Okay.
Yeah.
So this takes a G.
That's the return of function.
Okay.
Yeah.
Okay, this takes a G.
Yes. So so this G is of type L to A. And we have to give back a function from L to B.
Mm-hmm.
So we just compose that.
So we go and we return a function that takes now an L.
Yeah, so this thing goes from L to A, and this goes from A to B. So we just compose.
Yeah.
We just do this.
Yeah. Okay, fair enough. Yeah.
BTW, I think there is a const. It's just under function.const.
Oh, thank you.
Yeah.
Let's try it. Yay.
Hopefully it works.
Oh. Don't tell me I have to pass do I have to pass the type as well?
Yeah.
Yeah. Okay.
I mean,
I
feel like it was easier before.
So I can get what?
No. You're gonna go with no. This is your
No, but why is it wrong? Isn't that right now? No, what? Oh, sorry, I've got to say image. What? No, what the hell? How do I use this function? I just read the type signature. What?
It's like almost the same. It just takes in
B to A. Oh, I have this location.
Yeah.
Yes.
Yeah, you have to pass in. Oh.
All right.
Yeah, because obviously you can't infer location. That's why. I mean, maybe put an underscore there. I'm pretty sure I can figure it out. There we go.
Yeah. Great. So this should be implicit then, or there should be a version that's implicit. I don't know. Okay, well, that's good. So now we have an F, A, 2,
Ayson, I am reading what you're saying, and I would read it out loud, but it seems you are on the same. We're all on the same page. So,
we can invite you to the Zoom call
yeah, if you're
next
on
next
the
time or this time.
if you're on the Discord, just message me. I'll send you the link. Okay, I won't read it.
Okay. Right. So we have a function from alpha to beta to gamma. And we have now, how should I write this? So we have
this one is
an image of A, image of B. How do I write functions like that? We want a function from L to something.
No, not colon equal.
Oh, sorry. Yeah,
that's one.
Gonna get. Can I write this to do this?
Sorry.
We have something like that. So, yep. Okay, great. Type checks.
Cool. Okay, so.
Oh, do I need the parens? Well, I feel. No, I don't. Okay.
Okay, so we can, for image to A, we pass the L, then we get an A.
Yes.
And for image to B, we pass the L, we get, No, we don't even have to do this. So we're going to say if IAL, and then IAT. Yeah. I think.
Yeah, this looks right.
Nice.
Wonderful. ... So it's saying that I should write. I should write this as monochrome. Oops. Oh, I can't do that. Do I have to do? No. Okay, I'm not allowed to do that.
Oh, what?
I guess because there's like there's an implicit alpha here, isn't there? So I need to say that somehow. I don't know if I can do that with type. Can I do that with abbreviations?
There you go.
Oh, I need to give that as an implicit. Okay. I wasn't happy.
I think you can do at. I think you can still do at.
Oh, it's at.
Yeah.
Okay, so I've got to do that. All right.
Yeah.
Oh, and over C? What is over C?
Oh, over C is the over color function. It takes two colors and returns a color.
Ah, yeah. So this is another thing, which is like, can we have axioms?
No, but I think we can just define it.
Okay.
Yeah, I'll define it for you. Like, this is my first
So it
idea.
takes two colors.
Okay.
Which we don't have a type for. I mean, we have a type. We have a color type in RayLean, but
does it include transparent?
Yes.
Okay, then we can use it. Yeah.
I need to open something. Oh, I need to open. Yeah, maybe this is a bad sign for...
No, it's fine.
Okay, that's good. So color.
And
then we just take the first one or
the
second one.
Almost.
Okay.
If the second one is transparent, we take the first one. If either is transparent, we take the other one. And otherwise, we we take the first or the second one. Give me a second.
All right, so am I going to be doing a pattern match?
Yeah.
Okay, I can change this then.
Then the first one is the most important one. The first one is like the top color.
So if the first one is, so if the second one is transparent, then I take the first. Is that right?
Yeah, if anyone is transparent, you take the other one.
Transparent. Oh, switch. How do I? This one.
Yeah.
Oh, I can't do that. Must be atomic.
Can we go look? I think transparent is a function.
No, it's a value.
Okay.
But
But we can just pattern match on that. That's fine. If they're all 0, that's okay.
Oh, so I can't. So I've got to do.
4 zeros.
Okay. No, how can I do it like that? No.
The fiddly carrots. The side carrots. What do you call them?
The side, these ones.
Yeah, those ones. Yeah.
Side carrots.
I don't know.
I
One more comma.
I knew what you meant.
Oh,
no,
yeah.
it's the wrong. No.
doesn't work.
Okay, so that's because I'm doing the wrong thing. Failed to compare. No, how do I do? Because these are not tuples, right? They're just like two patterns I'm matching on. How do I do that? Because that's the tuple. Do I do that? No, if I want a pattern match on more than one thing, how do I do it? Do I put a comma here? But that looks like a product.
Yeah, I do
when I do that.
I think it is comma. I think you do comma after.
And then it's saying that.
Yeah, but
yeah, because it thinks I'm pattern matching on a pair. But I want to.
Yeah, so no parentheses around.
Oh, thank you.
And now let's see.
Failed to compile pattern matching stuck at. Color.mk should be RGBA. So there are 4 uint 8s.
Let me try just with one color just to check if the pattern matching works.
Okay. Okay.
Just check if it's not the color issue.
Sure.
I can just remove, yeah, it's a color issue.
No,
we don't have C1.
Right.
Just return C. Yeah. Okay.
That's weird. Compile pattern matching stuck at remaining variables. Maybe what? RGBA. Alternatives H1. What if I don't know, what if I just do color.mk?
Yeah.
Maybe it's confused with this. Okay. 1, 2, 3, 4. 1, 2, 3, 4.
Maybe they have to be named since when?
Well, I'm using 14.
Still.
I want to just try it. Just if in doubt, put parentheses around it. Maybe it was a mistake to go to upgrade. I only upgraded because the batteries required upgrading.
That's fine.
All right. Well, we can just do ifs then instead for now. Figure out later.
Okay.
I don't know.
I don't know if an if will work, but
well, we can say C1 because we got by
Okay.
Boolean equality. I
Okay.
can say
Actually, yeah, that might be enough. No, I think, yeah.
no, we need more. What? So I can't remember the rest of the logic.
C1.
Oh, okay.
Yeah. Oh, no. Yeah. So I think we can boil that down to one if. I think it's just the second if.
If C1 is transparent. Oh, yeah. Okay. Sure.
Yeah.
Okay, maybe it made more sense to do that anyway, but it's the power of pattern.
Does read nice.
Okay, so we've learned that we don't know how to pattern match a structure.
Yeah.
It's very
very humbling moment.
It's humbling extent. I'm sure have we should surely done that somewhere. Like this thing. Oh no, I'm pattern matching. We're pattern matching in inductive here. So can you even pattern match it? Yeah, because a structure should just be like an inductive with one constructor.
Yep.
All right.
No. I don't know.
Maybe you don't know.
Maybe.
Okay, so pre-rendered picture is a pre-rendered. What? Pre-rendered picture is a structure. Yeah, so I'm pattern matching here. This one works. Okay, so it's like an instance definition, but surely that doesn't make any difference. Well, I mean, I'm not matching on values here, so maybe you can't do that. But what would be the point? I don't know. Okay, so we can check that out later.
Yeah.
I have no idea.
Okay.
So weird.
We should be able to do that. I'm just doing something stupid.
No, I don't think it's stupid anymore because Keegan uses Lean quite a bit.
Okay.
It's more fresh in his memory. So
yeah, I'm pretty sure I've done
stupid.
pattern matching like this.
Yeah.
Like I don't get it.
Yeah.
It's such a weird error as well.
Yeah, I think maybe I should go. Well, I can't change the version now. Yeah.
It's okay. Like, let's move on. Next.
Move on. So what should I do with this over C then?
So we're going to use over C.
I've lost the page now.
Yeah, we're going to use it. Don't you worry.
Oh, it's a lift two, an over.
Yeah, for over we need it. Yeah. Yeah. Over takes two images and returns an image. I think it's okay to be a definition, like even monochrome, like it's okay.
I just wanted to see what was possible.
Yeah.
So this one takes
I think it just takes two images.
Yeah.
What the hell?
Both of type color.
Oh, sorry.
Yeah. And returns another image of type color.
Perfect. And it is just lift to over C.
Yeah. Nope. Maybe I was wrong.
Okay, so lift two should take a function. So this is color, color, color.
Yeah.
And then this should take. Well, I should have.
Oh, you should pass image one and image two.
Oh yeah.
Yeah.
Thanks.
Cool. Then crop, or well, first cond.
Cond, okay. So cond
takes an image of bool.
Mm-hmm.
And then 2 images of A, of alpha.
Okay.
And returns an image of alpha.
Mm-hmm.
Yeah.
So we have to okay, so this
Yeah, we have to write.
This is then, so we take, so we do fun
Mm-hmm.
L, then we ask if
if
I1
maybe
L,
we rename I1 to C or something. I don't know.
yeah,
Yeah.
then IA1 L, else IA2 L. Okay. Pond has already been declared.
Condi.
Pondy.
With an I for image.
No, Condi.
Why? Why would you choose Y?
Become Bondi.
Yeah.
I'm trying to revive the punning aspect of this.
Yeah, thank you. Sorry.
So I didn't do a very good job.
That was the, yeah, you didn't. uh,
Real quick, I think I figured out why the pattern matching didn't work.
Yeah.
yeah.
I think it's because uint is not an inductive type. So
yes, indeed.
it wasn't able to pattern match the zeros. So I like to find the same thing for nat, and that
Yeah,
worked.
you're right. The error message is pretty bad though, but I think that's exactly right.
That's the only reason, like that I can come up with why it doesn't work.
So it's not an inductive type. What is it?
It's a built-in or something.
Yeah.
It just has like a magic constructor. Let me just go to it. How do I? This is died.
Okay.
This instructive.
Yeah, it's a bit vector.
Okay.
Why doesn't this work
Oh,
anymore?
that's fun.
There we go. Yeah, so this thing, I should be able to go to it. Yeah. This function is overridden with a native implementation. So I can't pattern match on a bit vector.
Okay. Okay.
No, hold on a minute. So maybe you can pattern.
Yeah, no.
Something's gone wrong there. But yeah.
It's okay. I understand.
What does this mean?
Often. Well, yeah, what is double colon? Good point.
All right. Yeah, well, it must be this. The reason I'm using uint 8 here is because it needs to be this for the bindings.
Yeah, makes sense. We'll have to define our own color. Okay, so we've conned
crop. That's what we needed conned was for crop.
Okay,
so
well,
crop.
Ison says like
no.
maybe if we go back to that vector.
Yeah. Whoops.
That often is the constructor, but I think that too-fin is the constructor, right? Oh no!
Because we're using we got dependent types, right? So it's an indexed thing.
Yeah, but also it's a structure, not an inductive type. Structures have fields.
Yes.
Right. Too-fin is one field of type fin. Often is another field
of type
Nothing?
of whatever this is. This must just be some special thing we've not seen before.
Yeah.
It does look really weird. Why if I try and go to
he
definition?
says toFin is the constructor, and ofFin is the constructor, and toFin is the field.
Oh, so maybe this is a way of like
You name
giving
your
a different name to the constructor.
Yeah.
If you don't want it to be MK. Interesting.
Yeah, that's pretty good. Yeah. So you don't have bedweg.mk, you've bedweg.of.
Fin.
Fin.
Fine.
Yeah, it's not something I will use often.
No.
There's a pun.
Now we know. Okay. Prop. What is R? R is A. So they calls it R for some reason instead of C. We take an image. Is the right type signature? An empty image. So empty image is
It's monochrome
color
or transparent.
Oh, sorry. Yeah.
It has to be image. It has to be a type color though.
This one, yeah. So presumably this is also color. And this is color. Is that right?
Interesting. It has to be. But why?
So is this is this
fine.
empty im?
Yeah, no, you're right.
Okay.
Yeah, you're right. But that application mismatch is still there.
Yeah, because let's just get rid of this abrev. I think
Thank
it's just
you.
messing things up.
I think it's just that has to be infer curlies as well.
Lift 0
Or just
of
left
A.
A. Yeah. Here we go. Done.
Okay. Why have we got cond as a separate thing as well? Oh, cond is defined in terms of lift 3. Because this can be if then else.
Yes.
But we don't have that. Where we just define cond like this.
Yeah.
Because we don't have a separate, like if is not a function, is it in Lean? It's like a special thing.
And now,
Transform?
Yeah, because I think if then else is a function in Haskell, so that's why. But we just define it ourselves, that's fine.
Actually, there might be a
function dot if then else.
Yeah, there might be function dot ITE or something. Sometimes it's called ITE or they just have ITE. I can use check. Yeah, there's an ITE. There we go. Is that the ITE we want though?
No, no, definitely not.
It's a bit too fancy for what we.
Yes.
Yeah. For now, it's too fancy. There is no.
I mean,
Is
there's
there
cond.
find? Oh, cond. Yeah.
No.
So we
Not
can
the
put
right
Very close, but no. You want function.cond, not just con.
Mm.
That's good though. What other junk have they got on here?
Func.
Well, I like okay, so that's where the IT is also here, but no, if C then T else E is a notation for ITE CTE. So it is the same. It's just that it looks weird, but it actually we could use this.
No.
But it says here it's notation.
I mean,
for-
okay, yes, but like, yes, we could, but that's overkill now.
No, okay, yeah.
Like if there was a function that did the function application as well,
Yeah.
of applying L to each parameter, yeah, then we would use that. But no. Come on. Yeah, do you want to do transform?
Okay, so it's calling transform mu, which is not
Yes.
what I was expecting.
I think we start
that-
by defining transform S. And then just working backwards a little here.
So this we get. I don't know what to call these things. So
Yeah.
and then we get a. This is an image, right?
Yeah, that's
color.
an image. Yeah. And we
then
return an image.
we get
color.
another image.
Yeah, it makes sense, right? We're just transforming locations.
What's wrong with this?
Nothing. Oh, the image color needs a name, the first one.
Oh yeah, thank you.
Okay, so we take a location. Well, yeah.
Mhm.
And then
Do we transfer it by F and then?
Yeah, we transform that by F and then pass it to the image I. So FL.
Yeah, so it's just.
So IFL.
So it's just yeah.
Oh.
Isn't it this? We just
Okay.
no. Is it
Yeah.
is that right? Yeah.
Yes. I just never use the dots because I always get confused, but
Oh,
yes,
we can
I think you're right.
can make it can expand it if you like.
No. I should get used to it. That's good. Okay. And now that is basically transform actually. Because we've defined our image as our mu image, it is done. We can just call it transform.
Ah, okay.
Yeah. And it makes sense.
Perfect.
We're just transforming the locations of an image by some function. Okay. And then
So we got.
oh, then what would be nice is to make image an instance of a monoid for every A that is a monoid.
Right. So we can look at my thing for this.
Yeah.
So we need two instances. We need inhabited and we need append. We can say you put it on this side. So we need an instance of inhabited
Well, we can first do, just to make it easy, we can just do these instances for image color, and then do the more generic versions, just to go step by step.
Yeah.
Oh, well, default.
So
I think default's what you want.
Oh, what the? Yeah, sorry. The inhabit. I completely.
It's okay.
Yeah, we need to do that.
Yeah, there we go. Yeah.
And then default.
No, we just monochrome
empty.
Transparent or empty image. Yeah, perfect. Nice. And now let's do the.
So what about inhabited for image? Oh, yeah. Right. So the generic one would be you say so it's inhabited. So you have your. I think you write it like this. You have an inhabited this
Okay.
one. And you have your A.
Yeah.
So you say.
Left 0 or monochrome.
Yeah. So you say monochrome default.
Yeah. Nice. And now the same for a paint.
Yeah. Oh, so I didn't. Can I don't have to give it a name, do I? What?
Yeah, I think you do.
Do you have to give it a name?
Oh.
There must be some way of not giving it a name, right? Because it just inferred what we mean here. But I don't know if there's a way of not giving it a name. I suppose you put it on this side. Yes, you can put it here if you don't want to. No. No. Okay, so
I would even say don't do that, right? I would even say let's give it a name, and then I would even say the second default should be i.default.
Sure, yeah, why not?
Like then there's no confusion.
Yeah.
Yeah.
Oh, that's a pun. I like it.
Oh,
Remember how you?
Oh wow, that's
very advanced. That's the kind of puns we have here.
Oh my god. Yeah, that was unintentional.
I see you, eliminating the false.
Let's do a pun from 6 months ago. Let's just bring it up like it's nothing. I hated those no confusion.
No confusion.
Oh.
Is it still there?
I think it's no and then capital C confusion.
Yes.
There we go.
Is no confusion.
They're selling car insurance.
Yeah. It's not are you confused? It's like is no confusion.
We have we have in the UK we have car insurance. I think it's car insurance, and they advertise as confused.com. And like this is their brand. This is if you're confused, go to confused.com and then you have car insurance. Now I am confused. Like, why would it be car insurance? Oh. Yeah. Okay.
Append.
I'm too afraid to say anything. I don't want to cause any more conflict.
What do you think of this name? Append instead of monoid. Or semigroup.
Like
or semigroup.
I like it.
You think you like?
Yeah. I think it will help a lot of people.
Oops.
Screw all the effort I put in to understand what a semigroup is. but like,
Everyone should have to.
Why would I want to waste any of my time explaining this to someone? Like, if it's not needed, right? I do enjoy it, but like, no thanks. Like, it's a better future where people don't explain a paint to people. Like,
Yeah.
this is a better thing.
How do I define this then? So fun L
Iceland
or
says
it just needs to,
this is just over.
it's over.
Yes, correct. Correct.
Very good. But the over is for color only.
Mm-hmm.
So we've got to use our append.
But why is it for color only?
Because we have over C.
Because we have over C. What does over C need? It only needs a default.
Yeah. But we can at least we can define this in terms of lift 2 then. Lift 2 of
let's define
append.
an over C.
I don't.
Let's define an over C for something that is inhabited.
Right, but yeah, okay, so we need inhabited and BEQ.
Yeah, okay.
Yeah, let's do that.
And I think that's fair because these things were defined in a language without props, so it's okay to add BEQ.
Okay, so I put the constraints in like this too.
I think it's
oh, because they're just implicits, right? Square, yes.
Yeah.
BEQ.
Yeah. Mm-hmm.
Okay.
Um,
So color, I assume, is inhabited. It's a BEQ, but I guess maybe it's not inhabited. We should make it inhabited.
Yeah, we can do. Yeah.
Why didn't I make it inhabited?
I don't know. It's not the first thing you think of doing. Like.
No, I guess not. Maybe I didn't even know it existed.
Yes. Or like.
What's
it's pretty new to us.
Yeah. Where's transparent? Oh, it's here. Okay.
Okay, so Ethan asked like if we should merge the colors or not. But
good question.
I'm pretty sure when I was watching the talk, they were talking about transparency. But it's still possible that it could be a merging of colors. It's not impossible. But this definition is the easiest one for now. And then we still get all the properties we want. But because he says because like there is an alpha channel.
Yeah, we have an alpha channel.
Okay, so I do not know what alpha means. Sorry. That's
yeah, it's a good
transparency.
Is that the transparency? Okay.
Pretty sure. Yeah.
Okay. Okay, so there is potential to redo this in a more but then this
opacity.
Opacity, yeah. Okay.
Yeah.
So it means if the second one was if the top one was opaque, then you wouldn't see any of the thing behind it.
Yeah. But so then oversee cannot be generic.
Yes.
Mm.
We would have, I don't know, we would have a, would you have a type class for it or something?
No, I think we just have oversee. And we just create instance of a paint for image color. So we will need, we'll need a non-generic version of oversee.
I remember how this works now. You put this is a square bracket thing, right? Yes, there we go. Yeah, I remember. All makes sense, right? It's very. Oh, then you can't do that.
Yeah, that's okay.
I think you can still name it.
Yeah, let's
Oh, you
try
can
it.
still name it. Ah,
I
brilliant.
think so.
So was the other thing? The other thing was the other thing valid?
Beautiful.
Like why can you have? Oh, this just means it's implicit. But then if I made it non-implicit, what does that mean? Like for an instance.
I'm not sure.
That's funny, isn't it? That there's no place to pass this. Okay.
Okay,
Get to name it.
Yeah. Okay, so this is
How
the
do you put?
version.
Oh, you want to keep the other the non-generic version?
Yeah.
Ah.
You know, because then we can mix the colors.
Yeah, but the thing is that this instance subsumes the other one. So how do you express that with the instance?
I assume. Well, this is maybe a bad assumption that more specific instances would override previous generic instances. But that is a assumption that is not proven at all.
Okay. So I need an over. Maybe that's why it's called oversee.
Yeah.
Because it's over color.
Mm-hmm. Yes. Or we can only define the color version of a paint. That's okay. We never need to append regions, so it's not a problem.
Yeah, what does it mean to append
well, we can
bools, like
sense.
append regions? Yes.
It actually makes sense. Sorry,
yes.
It is useful. You can, if you have multiple regions and you want to, if you zoom out, you kind of are appending regions in a very weird way.
Yeah.
I would not use a paint for it, but technically. Okay, so that works. Maybe oversee, the current oversee can be called over I. Or ovary.
Ovary. Okay.
We can write.
What are you going to call this then?
I guess that's over.
Yes. And then the one that's specific to color.
Oh no.
We're just running out of names already.
Oversee.
Overseas.
Yeah, oversee.
Well, this is actually this is rubbish. What? There should be image.
No.
No, it's not. I'm confused now.
Okay.
This is color, right?
Yeah.
Yeah. Oh yeah. It's defining what.
Okay. And so for now, it can still be the equal transparent, but later we can do something smarter.
Hold on a second. Yeah, because that's the same implementation. Because of course, it's just
for now. No, but not only now.
Oh, I see. Yeah, but how's this? Okay, but all right.
Only as step 1. Later,
Yeah.
they will have totally different implementations.
I just want to
Keegan,
check something. We're checking that the color is transparent, right?
Mm-hmm.
If the transparency is 0, then technically we could have any color values in RGB, and the color would be transparent.
Yes.
Right, there would just be no color. So, like, do we
Yeah,
specifically
this is
have to
not
check
good enough.
0, or just that the alpha channel is 0? I'm not sure.
The alpha. No, it's the alpha channel is 0, right? So that's basically any. Yeah, or you can just ignore the other fields.
Good point.
So is it the? So if it's 0, then it means it's in. Oh yes. Okay. So we're just checking that dot. How do I do that? Don't I? Can't I just say a1 dot t? Well, what did I call it?
Yeah. So another way.
A.
Instead of over C, I mean we're losing a pun now, but Python like actually has a good point. We can just call it blamed.
Yeah.
Yeah.
I will miss the pun.
So this is an abuse of inhabited, right?
Yeah, no,
I don't want to say 0. I want to say
thank
default.
Thank you. Appreciate it. And now we can define a specific blendy.
This one.
Yeah, that one should just be over. And the other over should be ovary. Just swap their names.
Yeah.
Yeah. And then at the bottom on line 43 as well. Okay. And now blamed and blendy.
Yeah. Oh, we've got blend and blend. Yeah, so this one is the blendy one.
Yeah.
Blendy. And this one. I'm kind of blend.
Yeah. And then, yeah.
I wonder if we can.
Let's just see what happens. This is actually pretty
see what
interesting.
happens.
Can we specify a more specific instance of something if there's a generic one? Yeah, we don't even have to. It's not. Oh, we don't have to respecify inhabited. We just do append.
Oh, we don't, do we?
Yeah.
Just append. Ah, yeah. Append with this color.
That's just plainly. And no
Boom.
complaints.
No problem.
And now we can do.
I wonder what happens if you try to use it.
No, quite important. And also, we can now specify even more specific version of blamed, right? Which I don't know what that would be. I don't understand how alpha works. But I mean, if alpha is between 0 and 255,
yeah,
there's various levels of opacity and how things should blend. But
yeah, there must be some like
very generic
way of computing this. Yes.
Yeah.
Maybe even RayLean has it.
Yeah.
Like, have you doing arithmetic on colors?
Yeah. And isn't there a monoid or like a append, proved append or something? What do they call those? Or a safe append, where append isn't just a monoid instance, but actually proves the laws.
Yeah, let's have a look. Excuse me. Wouldn't be in data, would it? It would be in H-append.
I think that's the more generic version of append.
Oh, heterogeneous append. Okay, so that's not.
Oh,
Yeah, these are all heterogeneous. That's not quite right.
Heterogeneous. Okay. Yeah, so I want to go definitely up. Less heterogeneous.
Less heterogeneous. And maybe there's stuff that improve about append. Well, where would that be? That would usually in like basic or something. But so if you went like data list,
yeah, maybe like in list, it would be nice to just check what is it an instance of.
right. I
Is
see.
it only append or was the other instances? Maybe we find something.
Mem append con self.
No, just like if we just search for instance in the list folder, is that possible?
Yeah. Oh, it's oh, in the list folder, yeah.
Yeah.
Or M functor lawful B. Maybe there's lawful something or other.
Yeah.
Oh, I didn't know about this. Okay. So this is a lawful append. No.
Yeah, but that's what we're looking for.
Yeah. Applicative.
No.
Not append though. Well, you could make one, I guess.
Yeah, but it gotta be one.
What?
It has to be one. I can't believe there's not.
Oh. Possibly. Where would be? It should be an init, right? Lawful functor, lawful applicative, lawful monad.
Just skip the monoid. Who gives a fuck? Like, what?
Well, they haven't even given it its real name. It's like, feels very left out.
Yeah. Okay, it seems only control uses these lawful names.
Apart from BEQ.
Yeah.
A lawful get LM.
Okay. That's
lawful singleton.
Okay, I take it back. Lawful right identity. No, there's lots of lawful things.
I think I might have gone round to the beginning. I'm not sure. Take drop. Bit blast.
Yeah, like we can define our own.
Lawful hashable.
See that's important. Oh, can we look at lawful hashable? Just
yeah,
because I want to use that soon, but I'm pretty sure it's almost useless. Lawful hashable. If two things are equal, then the hashes are equal.
Yes.
Okay. Right? Yeah. That is the only thing you can say. Yeah. Okay. Okay, that's not as useless as I had imagined. Okay. But all right, so we can add these laws and And then we can finally write proofs about images.
Yeah.
Then, and we can a proper blend function and proofs about images, and then a render function to draw pixels.
Yes.
And then you can also have something that goes from SVG to this type of function, and then and even some of the RayLab library stuff if you want. But like, I don't want to draw a circle personally.
What? But Jessica Can't Swim it features a circle quite prominently.
Yeah, no, I do love sea circles, but I I don't want to write the math to draw a circle.
Oh, I see what you mean.
That's what I mean.
I thought you just didn't like circles.
Yeah.
So we might just explain to me again how the SVG would work. So you have your SVG, and then it doesn't have a.
You're gonna render it to the image, not the texture, the image. Okay.
Yes.
This is a data blob.
Yes.
That is just a series of 4 colors, 4 colors, 4 colors next to each other. It's just a string, right? So you can read any point. If someone gives you a location, you can do the math of where that location is in the image.
Yeah.
And then you can say that's the color.
You don't need, so what defines its, I'm just thinking like if you have a scale function or something like that, I suppose it has an initial width and height, which comes from the SVG file itself, or you pass it.
So we have our rationals, right?
Yes.
Yeah, and you're going to scale. So transform would apply the scale. And at some point, I was on a page where they explained this in that tutorial.
Yeah, you can recover all of the like rotation, reflection, translation from the transform function and scaling.
Sorry. Okay. I don't know. I don't know how to scale.
Well, you take the X and Y and then you just multiply it by the scale factor. So that's your F is just like a dot product with some vector.
A vector? Oh yeah.
Yeah, well, whatever, with this location. So you just multiply all the X's by a scale and all the Y by a scale. And that scales up the...
Does it?
So if you...
Yeah,
because you're asking like at the origin, so the origin doesn't move. But if you ask like something at 1, 0, oh, I see.
I think it just spreads everything. But you know what's really nice about this is we can write the render function and we just see.
Yeah, we see what it does.
Yeah, we just look.
Yeah.
You don't actually have to do this in your head. You can be more lazy about it. So maybe that's something we can do next time.
Yeah, yeah. We just we just pipe it through this draw pixel function. So you
Yeah.
have to pick your initial like width and height for your screen, and then you can just
Yeah, but I don't think you have to do that. When you render,
well, I mean, when you
only
render,
when you
yes, yeah.
Okay, cool.
Great.
Let's do that next time. And thank you, Ethan, for joining and giving all your great tips. Good to see you on the stream next time. And thanks, Keegan, for joining for the first time. Yeah, it's really good to have you. Finally.
Yeah, it was fun.
Yeah, cool. So I'll stop the stream, and then we can still chat.
Cool.
Bye.
Bye-bye, Twitch.
Bye-bye.